Okay, welcome. This is the FUCC means no supervised method of machine learning. We're gonna give a brief summary of how it works. Basically, we have data points in the space in the plane, and we are gonna give first. The first step is to give a random. Belongings or predictions from different clusters. We have three 100 points, and we are gonna organize them in three different groups. We have also this parameter that is m, that is it's how permissive the points are between each boundaries. This is a really important value, because for example, if we have a value of 1, it's gonna be more hardest algorithm, and it's gonna be similar to the k-means, and we don't want that, so we are gonna have some variation between the belonging of each data point in the different groups. The second point is to calculate the centroids of the different clusters. We use this formula, and then we are gonna calculate the distance from each point to the different centroids. After this, we are find and update our membership values in our original from our original table. We are gonna update using this formula how well organized is each point from the different group, using the distance as our variable. So basically, we are going to have new values of belonging to each cluster, and related to our threshold that is also here, we are going to do this process in an iterative way. So after we achieve this tolerance or the maximum iterations, we are going to have the different data sets, the different data points from our original data set, organized in the different groups, and also what is the probability of belonging to each group. Okay, welcome. Then we have the second approach, that is the Gaussian mixture model. Basically, you can have, for this example, just to simplify, for a lot of data in a one dimension, but also we can represent it in two dimensions. And the first step is to randomly initialize the Gaussians. What is a Gaussian? Basically, the Gaussian belt is a normal distribution, is an asymmetrical graphical representation of the distribution of data around a central value. Also, most of the data is clustered in the center. That is what we want to achieve between each iteration. And the frequency decreases uniformly toward the extremes, as we can see, forming like a bell shape. Then the second step is calculate the responsibility or probability of belongingness for each point. So basically, we can see here in the simplified example that these three dots, for example, are more likelihood to belong to the blue Gaussian distribution than to the orange, and the same with this. So basically, we calculate this. We are doing this with the function fit GM distribution that is related to the Gaussian mixture model. Then we have the third step, where we organize and we create a new Gaussian belt for the each data. So basically, we now have newer blue Gaussian distribution that it's gonna be containing different or more accurate dots in the space, or in this case in one dimension. But we can see the same in this graph in the plane with two dimensions, that basically we have a Gaussian distribution and that have an ellipse way. So basically, the advantages of this method is that it's a softer method, that it could be like the probability of each point to belonging to one or different clusters or Gaussian distributions. Also, the clusters do not have to be spherical, as in the k-means approach, for example, we can handle different dispersion in each direction. And as I mentioned before, the points have a probability of belonging to different clusters. Okay, welcome. We have the DB scan unsupervised algorithm for machine learning. Uh, in what consists this algorithm? The most important things are the parameters of epsilon and minimum points. Well, this is a simple graph, for example, of two variables in a bidimensional graph. We can, as humans, like see two groups that are obvious, but how the algorithm works? Well, basically, we are gonna give labels to each point of the data set. We are gonna classify these points between core points and non-core points. What is a core point? Basically, it's the point that fulfill our first parameters of radius, that is like the region around it, that can be taken to see how many points are in this region. So basically, if we have the number of points that were required at the beginning in this orange region, we can classify this as a core point, as a center point. And we are gonna do this with every data. Then, for example, we have the non-core points, that is basically the ones that cannot fulfill the requirements that were supposed to be at the beginning. Then we have to after we finish this process with all of the points, we are gonna go through a random point, a random core point. We are gonna try to do the same iteration process, and we are gonna find try to spread these clusters. So basically, we have a one core point, and if there is another core point near in the region, in the run region to the first core point that is a part of our first cluster, we are gonna be spreading this cluster until the algorithm cannot verify that the nearest points are part of it, or are basically non-core points. What is important to mention here, that basically after we do all this process of scanning and spreading our first cluster, we are gonna see that, for example, in these boundary regions, there are non-core points that basically are gonna be added to the cluster, but that are not gonna help to make it bigger. So then we can have like we can say that this algorithm is already finished for the first cluster, and then we can start to the second one and repeat the same iteration. So basically, we have here an example that these are our original data that are like in different regions. So the algorithm start to do a random validation of core points and non-core points, and we can see that this cluster could be classified as the first cluster, and this the second one. And also these x points could be classified as outliers that do not belong to any cluster in the region. What are the advantages of this algorithm? That basically we do not need to specify number of close clusters beforehand. We handle noises and outliers effectively, as we can see, and finds arbitrary shaped clusters that are non-spherical, as in the case of other algorithms like fuzzy means